Dear students, welcome to our class. In the previous online class, we have discussed about our first chapter, structure of atom, and we have discussed about the scientists Sir Humphrey Davy, Michael Faraday, J.J. Thomson, Rutherford, and James Chadwick. And also we have discussed the planetary model of atom that is introduced by Ernest Rutherford, and also the demerit of planetary model also discussed in that class. Today we are going to discuss about the new model of atom that is introduced by Niels Bohr. So that's why it is known as Bohr model of atom. Okay, it is introduced by Niels Bohr. He's a famous scientist. He introduced a new model by resolving the demerit of Rutherford's atom model. There are some demerits, we have discussed that related with Rutherford's atom model, and Niels Bohr here give more explanation for that model, and he just changed that into its style. That's why it is known as Bohr model of atom. So today we are going to discuss about the Bohr model of an atom and what are the main ideas introduced by Niels Bohr in that. Okay, listen for that. The first point is electrons revolve around the nucleus of an atom in a fixed path called orbits or shells. It is very important. The electrons are revolved around the nucleus in a fixed path. That path is known as orbit, or otherwise it is known as shells. So shells are the path in which the electrons are revolved around the nucleus. That's the first point. And in second point, electron in each shell have a definite energy. So electrons in each shell, there should be different shells are there. The electrons in each shell have a definite energy. Hence the shells are also called energy levels. So students, please listen here. There are mainly three important points introduced here. One is orbit, or otherwise it is known as shells, are energy levels. So electrons have a fixed energy. That's why each energy, each path or shell or orbit, otherwise known as energy levels. Third one, as long as an electron revolves in a particular orbit, its energy remains constant. It is very important. Here is the explanation that gives about the energy laws. We have discussed in previous class. The electron will collapse with the nucleus, but that will not take place in an atom. What is the reason for that? This is the reason. As long as an electron revolves in a particular orbit in which the electrons are revolving, neither their energy increase nor decrease. Their energy neither increase or decrease. So that's why we are call it as the energy remains constant. If the energy of electrons remains constant, the electron does not collapse with the nucleus. Okay, so the electrons are revolving around the nucleus of an atom. That path is known as shell, or otherwise they are known as orbit. Because of the energy of the electrons revolving around them, these are known as energy levels. Then the fourth point is that the energy of the shells increase as the distance from the nucleus increases. So nucleus is the center part of an atom. Around the nucleus the shells are there. When the distance from the shells increasing, the energy is also increases. The energy of the shells increase as the distance from the nucleus increases. So at the center there is a nucleus, then the shells are apart from the nucleus. Whether the distance from the center to the shells increasing, that time the energy of the shells are also increases. So the least energy for the shell that is nearer to the nucleus. That's the thing. The last point is that the shells around the nucleus can be numbered from near the nucleus as 1, 2, 3, 4, 5, etc. That means if the center is nucleus, for an example, if it is the nucleus, simply just presenting this nucleus, then shell nearer to the nucleus, the first one. So that is the first shell. Then second one, third one, fourth one, like that. Okay, that goes on, the number will be increases 1, 2, 3, 4, like that. Then all otherwise represented by the letters K, L, M, N, O, etc. Okay, that continues. That means the first shell is the K shell, and the second shell is the L shell, and third shell is the M shell, and fourth shell is the N shell, and the fifth shell is the O shell, like that. Okay, it's giving as represented in capital letter. Okay, K, L, M, N, O. I think you get the idea related with Bohr model. What are the concepts or ideas forwarded by Niels Bohr? So these are the points. The electrons are revolved around the nucleus in a fixed path. That path is known as orbit or shell, that have a particular or definite energy. That's why they are known as energy levels. When they are revolved around a particular path, its energy remains constant. There is no change in energy, whether it does not increase or decrease. Then the energy of the shells increase as the distance from the nucleus increases. From the nucleus, apart from the nucleus, it moves, the energy of the shells also increases. The shells around the nucleus can be numbered as 1, 2, 3, 4, 5 from the nucleus. Okay, or otherwise it is named K, L, M, N, or like that. Okay, clear? Okay, these are the main ideas related with Bohr model of atom. So Bohr gives further or more explanation related with the model of an atom, and it will be approved by others, and this we are going to study mainly in this chapter, Bohr model of atom. Bohr model of atom. Next one we are going to discuss mainly related with mass number and atomic number. Mass number and atomic number. Okay, for that we have to consider the main constituent particles or fundamental particles: protons, electrons, and neutrons. Proton, electrons, and neutrons. Okay, where is the position of the protons? Where is the position of the protons? The protons are present at the nucleus. So the protons are present at the nucleus. So nucleus is the position of proton. And where is the position of electrons? The electrons are revolved around the nucleus, and there is a name for that path. What is that name? Yes, that is known as shell, or they are known as orbit, or otherwise they are known as energy levels. Good. Then neutron. Neutron is another fundamental particle. Where is the position of the neutron? The neutrons are present at the nucleus. The neutrons are present at the nucleus. So the position of the neutrons are also in the nucleus. So clear? The protons are at the nucleus, and the neutrons are also at the nucleus, and the electrons are revolved around the nucleus, and that path is known as shells. For the practical purpose, for our fundamental or easier calculation, we are considering the mass of one proton as 1 unit. For the easiness, for the practical purpose, we are considering the mass of proton is 1 unit, that is 1. Okay, and the mass of neutron is also considered as what? It is also considered as 1 unit. Compared to proton and neutron, the mass of electron is very less. It is 1/1837 part of an hydrogen atom. The mass of electron is 1/1837 part of an hydrogen atom. Okay, so that means it is comparatively very less. For the practical purpose, carefully listen, for the practical purpose, we are considering that value is 0. The mass of electron is 0. Okay, it is only for the practical purpose, that is important. The value of its mass is 0 unit, and the proton is present in nucleus. Its mass is for the practical purpose we are considering as 1 unit, and neutron is also present in the nucleus, and its mass is considered as 1 unit. So my question is that here, if we want to know about an atom for their mass, we want to consider which fundamental particles. For calculating the mass, we want to consider which fundamental particles. Yes, that is, we want to consider mainly the proton and neutrons. We want to consider the protons and neutrons because they have the mass 1 unit, and electron is 0. We are considering for the practical purpose, we want to consider the protons and neutrons. Okay, so one question is here, if an atom that have 1 proton and 1 neutron, an atom that have 1 proton and 1 neutron, what is its mass? 1 proton and 1 neutron. Its mass is considered as 2 unit. 2 unit. Okay, so mass is considered as 2 unit. If an atom that have 2 protons and 2 neutrons, an atom that have 2 protons and 2 neutrons, how you calculate the mass? By calculate that 2 unit plus 2 unit, it is 4 units. So now we are going to discuss about the main idea in this chapter. This is mass number. So mass number is the total number of protons and neutrons in an atom. Okay, so total number of protons and neutrons in an atom is known as the mass number. The mass number is represented by the letter A. Okay, the mass number is represented by the letter A. So mass number is the total number of protons and neutrons in an atom, and it is represented by the letter A. So mass number. So clear? Mass number is the total number of protons and neutrons in an atom. Mass number is the total number of protons and neutrons. It is represented by the letter A. The next one is atomic number. We know that in an atom, the number of protons and electrons are equal. Number of protons and electrons, that is important. Number of protons and electrons are equal in an atom. That's why an atom is electrically neutral. We are saying that the atom is electrically neutral. But why the atom is electrically neutral? Because the number of protons and electrons are equal. Okay, so the atomic number is the number of protons in an atom. Number of protons in an atom is known as atomic number. Number of protons in an atom is known as atomic number. That is represented by the letter Z. So atomic number is the number of protons, and mass number is the total number of protons and neutrons in an atom. So students, that is A, that is the mass number. Mass number is the total number of proton and neutron, and atomic number, that is represented by the letter Z, that is a total number or number of protons in an atom. If you know the atomic number and mass number, it is easy to find the number of neutrons in an atom. How can you calculate the number of neutrons in an atom? By using these two things, mass number and atomic number. Just look at there. Mass number is the total number of protons and neutrons, and atomic number is the number of protons. The number of neutron is equal to number of neutrons. Number of neutrons is equal to mass number minus atomic number. Mass number minus atomic number. So we can subtract the value atomic number from mass number. We get the number of neutrons. Here, mass number, total number of protons and neutrons. Atomic number, that is only for protons. So if you minus that, we subtract this value from here. what do you get? This and proton, number of protons are cancelled and we get the number of neutrons. So we are formulate an equation. Number of neutrons is equal to mass number minus atomic number. If you subtract the atomic number from mass number. Okay. Then how you represent the mass number and atomic number in an element? How you represent the mass number and the atomic number of an element? If you consider X is an element, X is an element. So the symbol is not real. So X is an element, any element, if you consider any element. Okay. Then in the left side at bottom, you just write the atomic number. In the left side here, we write the atomic number, the value. I just write the symbol. You just exactly we are writing the value, atomic number, left side at the bottom, and the top portion we are writing the mass number here. Okay, X is an element. This is the atomic number, and here it is the mass number. By using an exact element, how can you write the atomic number and mass number? Look at that, carbon, C. So that is the symbol C. And we want to know the atomic number of carbon. Atomic number of carbon is 6. Okay. And the mass number is 12. Okay. It is easy to calculate many things by using this symbolization. What are that? If you know the atomic number, they are giving without informing that the atomic number is 6. We want to know that the atomic number is the number of proton. So what is the number of proton here? 6 protons. Then we know that number of protons and electrons are equal. Number of proton and electrons are equal in an atom. So how many electrons are there? That also 6. Then now we have studied how can you calculate the number of neutrons in an atom. How can you calculate the number of neutrons in an atom? Number of neutrons in an atom is calculated by subtracting atomic number from mass number. Subtracting atomic number from mass number. That is mass number minus atomic number. So number of neutron is equal to 12 minus 6 is equal to 6. Okay. Could you get the idea? If you know these two values, we can find the number of proton, number of electron and number of neutron easily in an atom. Okay? Is it clear? So what is mass number? Mass number is the total number of protons and neutrons in an atom. Mass number is the total number of protons and neutrons in an atom. What is atomic number? Atomic number is the number of protons in an atom. Then what is the relation between number of protons and electrons? Number of protons and electrons in an atom is equal. Number of protons and electrons are equal in an atom. Okay, these are the main ideas regarding with the topic. Okay, now I just give you some work for doing to familiarize with this topic. Okay, for that, for an example, I just give some idea related with this topic here. Please listen. Okay, so we are going to do this table. This from our textbook. The first question here, H11. The symbol is given here, H11. H11, by using that we want to find the atomic number, mass number, protons, electrons and neutrons in this atom. So H hydrogen, atomic number 1, mass number 1. So the atomic number is 1 and the mass number is here, it is 1. The number of protons. What is number of proton? Number of protons equal to the atomic number. So atomic number is 1. The number of protons are also 1. The number of protons and electrons are equal in an atom. Number of protons and electrons are equal in an atom. So electron is also 1. Neutron. How can you calculate the value of neutrons? Number of neutrons is equal to mass number minus atomic number. Mass number minus atomic number. Mass number minus atomic number. So the value is 0. Number of neutrons is equal to 0. The next one here, helium. Helium 24. So that you do as homework. The second one, you just do it as your homework. 2, 4. Then third one, Li. Lithium 37. 37. Now we are going to do this one. Lithium 37. So students, what is the atomic number from this symbol? What is the atomic number here? Yes, the atomic number is 3. Then what is the mass number? Where we write the mass number? The mass number is right at the top of the left side. Top of the left side. Left side top 7. So the mass number is 7. Then protons. Number of protons equal to the atomic number. Atomic number is 3. So number of protons is also 3. Then electron. Number of protons and electrons are equal in an atom. Number of protons and electrons are equal in an atom. So that is equal to 3. Then we want to know the number of neutrons. Number of neutrons is calculated by mass number minus atomic number. Mass number minus atomic number. Mass number 7. Atomic number 3. Mass number minus atomic number 7 minus 3. So that is equal to 4. The number of neutrons is 4. So that is very easy. This type of question will always ask for our examination. So lithium, it is symbol, then it is the atomic number, at the top it is the mass number, then atomic number is equal to the number of electrons and protons, number of neutrons is equal to mass number minus atomic number. By like this you just calculate the answer for carbon, neon and argon, okay, and complete the table. This is also for your homework. Okay, thank you students.